So one of the best things about Python is that it is very easy to load, manipulate data, and although they say data is king, but you can't. It's like cooking. You really need to have good ingredients and to be able to sort of prepare them well in order to cook a good meal. So without further ado, let us go into today's course. I'm going to share my screen right now. And okay, so yeah, so I was saying that Python can easily load data. Today's content will be largely looking at both NumPy and Pandas. These are two very extremely popular libraries that you see sort of being used in almost every Python script that you ever come across with. So yeah, let's go into it. So let's assume that we want to read a bunch of data, and let's look at the data from what we've been looking at so far, which is the Go work data. Okay. So now gets loaded onto Google Colab, and we're going to load it, open it as a file. So go work. So this command opens up the file gowork.csv, more like a file pointer, and it stores it in the variable called file. And in order to get the so-called the content from the pointer, we do a .read. So the file contents will be equals to file.read, and this command in fact reads the contents of the file pointer, which is gowork.csv, into the variable called file contents. And when you do the printout, this then prints out the contents of the file. So as you can see, the files are largely so-called there's no particular structure to it, so they are arranged in terms of rows, but there's no proper demarcation of columns to that. So it is really just like a flat file. You're reading it like a flat file, like a normal file, and I'm just doing the printout for a normal file. But it is really hard to so-called to interpret text in that manner. So what we usually do is we would store in a very unique data structure, which they call so-called a pandas data frame. And the first thing we do is let's try. And basically we'll be using two main libraries, as I said earlier, NumPy and Pandas. So let's try to use the library Pandas right now to read in the CSV file. So Pandas has this very convenient function called read CSV. So CSV, and immediately it reads the entire CSV into the variable df. And notice that when I print it out, they're in fact properly arranged in terms of columns. So so there is so-called a structure that is being done to it after you use the read CSV file from, read CSV function from the pandas library. If we want to display using the notebooks theme, this can be done as well. So yeah, so one of the most basic things you can do is to convert the dictionary to a data frame. And here you see that I've handcrafted a few so-called a particular dictionary. So in the earlier sessions, we talked about different data structures. One of it is a dictionary, one of it is a list. Over here in this handmade dict, you will find that on the left side, there are so-called keys. So there's a key of a breakdown, rain, oversleep, ML lecture. And on the left side, that's on the left side. On the right side is the value. So the values will be a list of values. So it's slow, yes, slow, true, false, or etc. So one of the first things that we want to do is we want to convert this this dictionary into a data frame. So what we can do is we can simply call this function up. And this would then create a data frame like that. So one thing I forgot to mention, if I want to convert this to a data frame, I can also do it in this manner. So this in fact is a data frame by itself already. Okay, so that's that. Okay, let's go through the next example. So there are a lot of data types that can be managed using a data frame. So using pandas. One of it is JSON data type. So in this example, we'll be loading the example. We'll be loading the file weather.json. And let's first load the the file in the notebook. Sorry. So once again, this command sort of opens up a pointer to the file weather.json. The contents are not really loaded yet. You only get to load the contents when you call this command. This is when the contents are being loaded up. So once you load up, you are able to, in a way, convert this to a data frame, and we use a formula called JSON_normalize to convert this to a data frame. Okay, let's look at this, how this looks like. Data is undefined. Did I do anything wrong? JSON. Yeah. So this converts the part of the JSON file into a data frame. Maybe let's take a slightly closer look into what this weather.json is. So if I double click on this, it tells me, you notice that the first thing I'm looking at is data item. So I think there should be items somewhere in my in my JSON file, and here it is. So you see the items are there. So I'm actually taking the so-called the dictionary, the values from this items key, and I am taking a few things, the forecasts, and then which will consist of both the area and the forecast, and then I'm also taking the metadata, which is update timestamp, valid period start and valid period end, which is why you see these figures, these column names place. Okay, so excuse me. df.head gives me the top 5 rows of the data frame. If I were to do df.tail, this will give me the bottom 5 rows of the data frame. So these are the 5. So okay. The next thing we want to look at is what happens if I want to load the data from web. So over here we have a so-called the voice API. This gives us the Euro USD so-called conversion pair from the API, and this returns us with the response result. And let's try to so-called in a way print it out. So dictionary equals to response dot JSON. So it is in the JSON format, so we're going to convert it to the we're going to extract the response out from we're going to extract the JSON from the response. Yeah. So data. So essentially, this is what it looks like. The conversion rate 1.1795. Okay. The first thing we're going to do is let's say we want to convert a few pairs, not just Euro to USD. We want to convert all these following pairs from freeforex.api.com and display in a data frame. Then we do it. So maybe the first thing we want to do is we want to find a way to get the response as well. So it will probably be something very similar to this. So first thing is getting the response equals to request dot get. I'm going to just copy the line there. And Euro to USD is one of them. The other things that I want to do is Euro to, so these are all the rest of the data that I want to take. I'm just be lazy today, so yeah, so I'm just going to copy the information down. I think better to just remove the spaces just in case. Yeah. So this should get me the response from freeforexapi.com, and let's try to print it out. So equals to response.json and .json, and then data. Okay, very nice. So it gives me the rates for each individual so-called forex pair, the rate of conversion together with the timestamp. So let's try to arrange this properly in a way in like a data frame form. So the command for this is quite straightforward. What we need to do is we need to call the from dict so-called command, and that actually that's about it. And we need to tell it to convert it from the key value pair from the rates. So that's about it. So df equals to pd dot data frame dot from dict data dict rates equals to index. So this line essentially converts the entire dictionary into a data frame. If I were to print this this command out, you can tell that it's very nicely formatted. So every single individual so-called row, there's a forex pair, and then there is a rate of conversion together with the timestamp. So you notice that it is pretty straightforward in a sense to work together with data. And one of the things that we try to do is regardless of the data, not regardless of the data, regardless of the regardless of the data that we get, sometimes we try to convert them into a data frame format so that it is easier for us to manipulate with it and to work with it in general. So the next part of this presentation, so we'll be talking about so-called a library called Pandas Data Reader. So as you may know, Python, the strength of Python lies in the ability to in a way dynamically install a lot of different libraries to use together. So a language by itself is just itself, but because there are so many supporting so-called libraries that prop Python up, so it becomes very easy for you to do many things. So Pandas Data Reader is one of them, whereby it allows you to grab data from the internet. So earlier we used the HTML request format. Right now we're going to use something a bit different called the Pandas Data Reader. So the first thing we are going to do is we're going to install it. So this is the command to install. It seems that everything is satisfied already. And right now we're going to do a data reader of the stock from Google. And as you can tell, so this is the so-called the stock from Google. And I'm going to display only the top 5 rows of the stock. Okay, so so I have this data on the data frame.df prices. So usually some of the things that we do is we try to understand a little bit about what the data is, how for example, how many rows are there, how many columns are there. So let's go about into it right now. So I want to find how many rows, how many columns are there. usually what we do is we have DF prices shape. Know what we essentially what we want to do is want to find the shape of the data frame. Yeah. So we notice that there are 5 columns there: open, high, low, close, volume, and there are 1,259 various observations of various rows to that. So the shape essentially tells us how many observations there are. There's another formula here. There's another super attribute, or function that you can call, which is info, and this gives us the info of the data frame. How many rows, how many columns are there, what types they are from. Usually, sometimes we do that pretty often as well to know what types there are. Are there any nouns that are there that we should take care of? Later on during the presentation, you realize that there will be some times that you need to in fact fix all the noun values that are there. You can also get statistical descriptions of the actual data. So, for example, and these in fact are quite intuitive. So I can just call describe, and this describes the various statistical matrices for each column. So, for example, for open, count will be the number of values there are. So 1 to 5, 9. Then you have the mean of the values, standard deviation, the minimum, the maximum. Then 25, 50, 75 will be the percentile. So at 25 percentile, what's the number there? At 50 percentile, what's the number at? 75, what's the number at? So these are, in fact, pretty how to say, they're pretty good ways to, in a way, very quickly get a very good feel about what your data is like. Are there many missing values? Are there particular keyword to any is there any bias or skewed to any particular class or any particular value to it? So these are just very useful, I would say very useful functions that Pandas gives you out of the box that can just use them. So yeah, so there are other things that we can manipulate the data in as well. So for example, let's say for example, we want to extract a single column. So for example, you want to extract, let's say you want to extract just the close column. And let's just look at the top 5 values of close. So this command gives me the it first gives me the column close of DF prices data frame, and gives me the top 5 values of that column. So yeah, as you can see. So then we can work with the numbers in this columns. So for example, I want to know the sum of my volume. So I first extract out my volume, which is VOLUME, and then I can simply do a sum, and this gives me the sum of my volume, my entire volume of the data frame. The mean of my open price. Once again, in fact, these will be open. So mean, and this gives me the mean of my the column in my data frame. And I can also call the median of my high, which is here. So these are the numbers that you get. So maybe you can just do a very quick counter check. The mean of my open, 1020, 1020, 2348, 2348. So it's correct. The median of my high, the median, I don't have the median here, so yeah, I can counter check there. But now you can suppose that they should be correct. Yeah. So next thing we want to do is we want to slice out so a certain piece of my my data. So we can do that by using the row number, which is prices.ilog. So what this tells me is that I want the integer location or index location at 100. So yeah, basically that's how we read, how we interpret this command. So if we do that, this will be the number at row number 100, index 100. Okay. And if I want to look at the location at a certain date in particular, so in a certain date in particular, so let's look at firstly. So there's a certain date that I want to look at. So how you do it is that we do a df prices.lc, and we can simply do this. Sorry. Yeah, so this gives me the row that corresponds to this single number there. Okay. Okay. If I want to take a so-called a slice containing certain rows, I will then have to do this. So I log 5 to 10. So yeah, so it gives me the row number 5 to number 10. Okay. And if I want the slice containing the rows between February and February and March, so it's going to be very similar again to what we have above. .loc 2019. So I'm going to copy, use the format that was being supplied to me, 31, all the way to 2019. 001. So this is for January, and what I really want is I want between February, which is 3, 2. So this will be the numbers that are between February to March. Yeah. So this will be it. So if I want something from October onwards, so how we do it is that the date of October will be at the start, and then we'll do it until we have the colon, the last until the end. So for example, prices.loc 2018 01 all the way to the end. So it gives me from 2018 all the way to the end. But yeah, and then you realize that but this case is all the way to the start. See, can I do this? Yeah. So this will give me from October 2018 to now. Yeah, it's good. So this was written in 2018, so some time back. So anyway, yeah, but the information is still as relevant today as it was then. And okay, let's if I want to find something that equals to a certain value, for example. So so let's say if I want to get the date that is equals to 2018. So where are we? Okay, here. Okay, so df prices, df prices dot index, and 2018 12 10. Okay, so notice that we use the index column, but this is also because this is the index as well. Okay, so the next thing we do is let's do an exercise on getting the slice of close between two values. So similarly, you can just do this. Greater than 100. So this is the first condition, and the second condition is this. Less than or equals to 900. So essentially, I want indexes of where these two conditions are true. I want to find out the indexes here. Sorry. Let me see where did I go wrong? Here, prices. Here. Here. Okay. Okay. So I need to encapsulate both in so-called a round bracket. It's because I'm actually going to end these two conditions together. So yeah, that was my mistake. Sorry. Yeah. So this is how I combine both conditions together, and I first have the indexes whereby the values of close is greater than 800, and then I also have the indexes whereby the value of close is less than equals to 900, and then I'm going to take the so-called intersection of the two. And these will be the indexes whereby these two conditions are true, and I'm going to select the DF prices out of that. Okay. Hope all is still fine so far. And lastly, yeah, so if I want to have a slice function as well, so again, I think and I want to store in the variable, and that's how we do it. Okay. I'm going to stop here to take a break. Okay, the final part of this very short presentation deals with something very important, which is on data cleansing. So yeah, so let's get to it. So okay, so first thing we do, we want to upload the Star Wars people data. Interesting to note, this used to be a live API. It was maintained by somebody, but I think in the end it cost too much, and he decided to call it a day. Fortunately, before he killed it, we managed to get a small little snapshot of of the API, and so we can reproduce it as a CSV file. Else we have to redo the entire example. Yeah. So anyway, yeah. So this is how the file looks like. So there's the there is simply there's I think this will be the people that are in the Star Wars. Then you have the birth year. Maybe something important in trivia is like the eye colors, the gender, the maybe the height, yeah, skin color. That's about it. Yeah, but basically, yeah. So basically, why we are talking about this is that the key part of machine learning is how we in fact we clean the data that is given to us. And in fact, I would even go as far to say that maybe even up to 80% and even getting more and more time is really spent on just making sure that the data is correct. And it's true, you know. In fact, some of the very recent projects that I worked on, in fact, a huge amount of time is being spent on just ensuring that data is sound, the data is properly labeled. That's just the first part. And we spend large amounts of time just to get that to a decent level before we even start building the data, or rather building the model. And the main reason why is so is because I mean, if your original data is not labeled properly, there's so many issues with that. Whatever model you're going to come up with, it's not going to work. So there's no point at all in making sure that your model is perfect if the foundation whereby it stands upon, which is the data itself, has so many issues. So yeah, and then by and by, as data gets more and more larger, we find that there's the need for proper data pipelines, data lakes, data warehousing, for them to be so-called built and set up, just as in a way the same thing, just as a foundation before any models can really be built out of them. Yeah. So yeah, just a short sharing. So anyway, so let's look at what we have over here. So we showed what is the data frame earlier, and let's say if I want to drop a few columns here. You notice that there are some columns here that are probably not really required. So let's say I want to drop the creator column, which is the date that maybe the column that row was inserted in. I want to drop the flames that the actor maybe point or that the character appeared in. We want to look at the home world. I think I don't need that, and maybe some others are just for fun. The species, starships, URL, and maybe lastly the people. Yeah. So yeah, so this creates for me the new so-called data frame with all the unnecessary columns being dropped. Notice that the drop columns are still in the original data frame. They're not really they're not gone unless you ask the data frame to be modified in place. So it is possible that you can ask them to modify that in place. I can do it like this. I'm not going to cut all this down. I'm just going to copy all this. And I can just call an in place equals true, and that would also in a way edit my columns in my original data frame itself. So I don't really need to reassign them to another variable. Okay, so that is it. Yeah, I may want to rename the columns so so maybe birth year I want it to be like birth YR. So these are just things that you are able to do. You're able to do. Yeah. So yeah. So no biggie. I can rearrange it to any time in any way that you want. Again, I just put it there as a way to do it. Yeah, and next thing is really quite important. So it is on if you have so-called NANs like this. So you probably want to replace them, and it's usually not a very useful thing to have. I mean, it's not useful is one thing, but may result in other issues that may come about. So sometimes you want to ensure that some of these values are being replaced and they don't really appear in your in your in your in your in your database, or rather in your data frame as you are trying to train. So the first thing we're going to do is we're going to replace all the n-a's unknowns with MP with no numbers. Do we have anyone here? Let me see. Do you have any unknowns here or NA? We have one unknown here. Yeah, so I'm going to replace this. So what is this unknown? Birth year of R5D4. Birth year of R5D4. So you can tell that now instead of being unknown, it's now NaN. And essentially, I'm going to replace all my NAs, all my unknowns, or some of the other things that I don't know of into NaNs. So it's just to ensure that if there are any cells that I am really not sure what they should be, they are just being replaced in all, or rather represented in all the same way. And after doing this, we can just see check like where are the nulls, df.isNull. So this tells me how many nulls, or rather is the particular cell a null, which is the NaN. Yeah, or I can even know like how many nulls are there in each column is null dot sum. Yeah, so these are number of nulls there, and this is in fact very useful because it tells us for example, if there's a column whereby almost up to 75% of them are nulls, then maybe we may want to drop the entire column. So we do use this really often when we are looking at which are the columns that may not be as useful just because the data there is really so incomplete. Yeah, and data frame gives us the very nice way of dropping all the NAs by this command df.dropNA. So these drops are all the so-called all the rows, observations or records that have the NA there. So yeah, essentially this gives us a really clean list of the data frame. Once again, the original data frame is not changed unless we do it in place. So DF is still as with all the NAs. So if I want to drop all the columns instead that has an NA, I can do it as well. Equals to 1. So this drops all the columns which has the NA. Okay. So another thing that we usually do very often is we remove away duplicates. In this current set of data, we don't have any duplicates. So a common way is that yeah, but we can artificially create them. So we're going to append myself to myself. So this will be you can tell that this is one the original data frame. I appended myself to myself. So the data frame has records that are repeated once. And to remove duplicates is actually also very simple. We can actually it's just one line of code. I mean, in practice, right, it is of course not so straightforward as one line of code for everything. Just showing this as an illustration. In practice, what usually does is that you may have 5 columns that are the same, or 5 or 7 columns that are the same. And maybe based on various business decision or based on other things, we decide that if these 5 columns are the same, then you want to drop them. So these are some of the considerations that you probably have to go through as you are working out with your data project. And yeah, a big part of data cleansing is really to format the data in a style that that the data is able to support or to work on. So so let's look at an example, which is the dates. So in this example that we are using, we are trying to say that we are going to remove away the the time portion of the date string. I can tell the time portion, the date string is pretty long, and what I want to do is I want to just take the first 10 characters out of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to just take the first 10 characters out of it. And we do it by this function over here. So if we apply this to the column, it will then just take only the top. The first 10 characters are out of the data frame, the column in the data frame. Okay. So so that's about it. So can we achieve this in a single line? Sorry, can we achieve this in a single line? Run a function on each row that rounds off the height to the nearest 10. Okay, so we can do it. We can definitely do it. It's just that we did not teach this so far, but there's a way to do it, which is to use a lambda function. So okay, firstly, we want to talk about is we are going to run it on the column height. So the column height has got to be changed, and column height has got to be changed by a certain way. And the easy way to think about it is that we are going to apply a certain function. We're going to apply a certain function, and hence we're going to have something called apply. We're going to apply a certain function, and we're going to apply it to every single row in that column. Okay, so we're going to apply to every single row in the column. We're going to call that row, the value in that row each. And for every single value, we're going to round it to my nearest 10. So essentially, this is the exact operation that we are going to do for every single cell in that column. Okay, so this is all that is to lambda functions. So we are going to work on a single column. For that column, for every cell in that column, we're going to call it this variable, which is in this case age. And for every cell in that column, I'm going to do this operation. And after doing this operation, I'm going to put it back into that cell itself. Essentially, this is what they call a lambda function. And we have to prepend this with the word lambda. And this is essentially all that is required. And you'll get the height in rounded up properly. Okay. Finally, we can do an output file by doing a df to CSV, and this will be output as a CSV file. So yeah, that's about it. Okay, so I'm going to stop sharing now. Yeah, also hope this session has been useful for you today. We covered largely on pandas, and essentially the main thing is to give you all a good feel about how to work with pandas, how to manipulate data, get to select columns, select rows, remove so-called non-integers, or rather remove any ends, So these are very typical operations that we need to do. We also talked about finding the mean, the median, the average, and also describing the data. So again, once again, these are often things that we do in a special process that we call exploratory data analysis. So in EDA, we try to find out a bit more about the data, what the data, some of the various biases that are present in the data that we can, in a way, fix, or in a way also try to account for, or try to clean up a little bit more. And this process is actually quite long, and it's very it's not complex, but it's very long, and it's very important because as I said, it builds the foundation in order for your models to build. Okay, so that's all I have for you today. I hope you guys enjoyed the session, and I'll see you guys very soon. Cheers.